In December 1872, sailors spotted a ship drifting aimlessly in the open Atlantic, some 400 miles off the coast of the Azores. The British vessel that discovered the Mary Celeste brought the brigantine to Gibraltar. There, inspectors found the wooden hull perfectly sound and the cargo hold largely undisturbed. But her captain, Benjamin Briggs, his family, and every single crew member had vanished. They left behind their possessions and their shelter, creating a riddle that would puzzle the world for more than a century. Experienced mariners abandon a seaworthy ship in the middle of the ocean. Below deck, personal belongings were left as if the crew intended to return. The cabins were dry and the food supply was untouched. The only evidence of their departure was a missing lifeboat and a snapped tow line trailing into the wake. Investigators found the most important clue in the hold: 1,700 wooden barrels of industrial-strength ethanol, worth a fortune, yet completely unlooted. For generations, these physical contradictions fueled theories, ranging from ruthless pirates and mutiny to sea monsters and supernatural forces. However, the pristine cargo and untouched belongings eliminate human threats. To find the culprit, we have to look for an invisible force. During the salvage inquest, inspectors found exactly 9 barrels entirely empty. Through the porous wood, roughly 300 gallons of highly volatile ethanol had seeped out to vaporize in the enclosed space of the hold. As the Mary Celeste sailed from the freezing New York winter into the warmer waters near Portugal, the temperature below deck climbed. Once the hold passed 13 degrees Celsius, the flashpoint of ethanol, the air grew thick with combustible gas, waiting for a trigger. The shifting weather had weaponized the hold into a massive, invisible bomb. If a massive explosion occurred, investigators should have found a charred tomb. Instead, they found 0 scorch marks. Chemists from University College London and the University of Manchester recently recreated these exact conditions to test how a blast could leave a ship untouched. Using a scale model, they found that cold ethanol remained stable, but warmed ethanol vapors replicated the volatile environment of the Azores. When they struck a spark, a massive pressure wave explosion ripped through the model. This specific fire feeds so greedily on the invisible gas that it lives and dies in a fraction of a second. It consumes the vapor, but vanishes before the wood can singe or blacken. The unburned wood of the Mary Celeste serves as the chemical signature of a vaporous flash fire. Whether from 2 barrels rubbing together or a sailor opening a hatch with a pipe, a spark was finally struck in the darkness. The resulting blue fireball would have been enough to blow the hatches open, flooding the deck with heat and blinding light. Believing the remaining 1,600 barrels would shatter the hull, Captain Briggs ordered an immediate evacuation. They tied the lifeboat to the Mary Celeste, waiting for a secondary blast that never came. A sudden squall snapped the tow line, and the crew was lost to the deep forever. The stranded crew perished, while their perfectly safe ship sailed onward to Europe without them. Applying the rigid laws of chemistry finally demystified 150 years of wild speculation. Scientific deduction reveals that reality is often more tragic than any ghost story. For more forensic deep dives into history's greatest mysteries, make sure to like and subscribe. Tell us in the comments which mystery you want us to solve next.